Hello, this is a short introduction to sourceCREATOR. We start with an online demo and end this video with a bit of a description of how this works internally. So let's begin first the online demo. If you go to sourceCREATOR.io, you can see the website. There is an online demo. You can click on the online demo button. Let me give you a quick description. There is a workspace. This is the blueprint of your application that you're developing, and on the left side you see a bunch of smart templates. Now before we start doing any work, I would like to say a word about Hardware. Hardware is a company that that makes these IoT kits, and the way you actually create applications is by using the C and C++ programming language, as you can see on their GitHub page. Here is a demo. It is a demo that does initialization. It creates a lot of stuff like temperature sensors and LEDs and stuff for the kits. So what we are doing here is that, for example, you can start by dragging and dropping the main part, which gives you the backbone, the main part of your firmware or prototype that you're developing for the kit. And note that actually it generates code in two different files when I drop the smart template. Now with this initial code, the kit might not do much. Then you can actually choose to add any of these other parts. For example, let's add a new LED, and as you can see, sourceCREATOR is actually generating the code. These 3 lines were added. On the left side here you can see the code. On the right side you can see the addition after adding the LED. So that's it. This is a very simple, quick introduction to how the front end of sourceCREATOR works. This is an online demo. It's running on a cloud server, and it has very minimalistic features. For example, you can change these properties. You can call this my LED, for example. But this is by no means what sourceCREATOR would look like in the future. We are hoping to make it much more sophisticated than this. You can see I've changed the property, and the change was reflected here. That line was deleted with LED01. This new line was added with the new name, my LED. Now you can do a lot of stuff. For example, adding a lux meter. Let's add a lux meter. You can continue basically developing your prototype like this without having to understand everything about the complicated framework that Hardware provides for their hardware. So this is a good way of making a prototype, and as well as but basically learning how the framework works, how you're supposed to use the functions within the framework. You can do stuff like adding extra LEDs. For example, if your kit or hardware has an extra LED, you can delete components. You can see we've got 2 LEDs here, my LED, the old one, and the new one, which is LED 03. If I delete the old one, you can see that sourceCREATOR has deleted the code for you. So this is how sourceCREATOR works. From a user perspective, this is how it works. It's worth mentioning that developing these smart templates for use with sourceCREATOR at the moment is not possible with this front end. But we are hoping to do that, add that feature also to the graphical front end. So what we did for this demo was we took this original source code from Hardware, and we broke it down into these different components, these different smart templates. So let's move on to a few concept animations because the front end is not quite finished yet. We need to show you some stuff in just concept animations. The first video I would like to share with you is generally just showing you how of keeping smart templates as well as the source code in sync at all times. So we drop a file, it takes blue and purple. If you drop a blue component, it takes the output. Blue component can take green, purple goes directly to the file, and you drop an orange, and it actually is basically giving you the orange lines, which are automatically fed into green, automatically fed into the blue, automatically sent to your file F1. Now if you start editing stuff on the left side, on the graphical side, they change on the code. If you start changing them in the code, they change on the graphical side. This is what it means that the editor keeps both sides in sync at all time. If you delete one line, you can delete on both sides. And this is crucial because you don't really want to get users to learn how to create and modify these components. Everything has to be done in a so-called intuitive way. The second video I've got is showing you that the concepts in these smart templates actually can be expressed using the graphical interface. For example, we go through dropping a file again, takes blue and purple, blue component, purple component, we drop an orange. Notice how orange output is automatically fed into purple. Now, if we drop a green component that takes orange, the output of green went into blue because that was how the blue was designed. And now green has some tags for the orange content, and therefore the system would automatically feed orange content into green as well. Now, there's a concept of, in a smart templates, we have a scoping, just like any programming language. For example, if you want to limit the scope of the output from orange into the purple components only, this is what you do. You just delete the orange and drop a copy of it inside purple. So this is what it means in terms of defining a smart templates and your code. Everything can be expressed in the graphical user interface. The third video actually shows you a concept that basically can be very actually critical for programming. Again, we go through dropping a file, blue component. Here what happens is that the yellow component is output to blue, but it's not just the line yellow that you see on the right side being generated. There are two lines that are shared, so shared amongst all the yellow components. So if there is a second yellow component, if we drop a second yellow component into our workspace, you see the white lines aren't actually duplicated. This is not just a concept animation. You can actually try this concept in the online demo as well. It's working at the moment. Same with the purple, it needed the shared lines. Now if we start deleting any of these lines, the shared lines won't go away until all of the components that need the shared lines go away. So yes, these smart templates can actually be very helpful and smart. The next step is actually showing you how these smart templates work. Again, to the website, if you click on Learn, you can see a few PDF files and videos. This is how it works. The high-level workflow is that basically you have a graphical user interface, as you saw in the concept animation and the online demo. First step is somebody, like for example hardware in this case, takes existing source code in any programming language, and via a future version of our graphical user interface, our front end, the vendor, the software vendor who is selling this kit, for example, is able to, by doing stuff like selecting, clicking, dragging and dropping, basically they're able to break their source code into various different types of smart templates. So the interface helps with creating these smart templates in the future, will help. Then what happens is that somebody, the users of these frameworks and the smart templates, they receive bundles of templates, whether it's free or open source, and they're able to use the front end. In this case, we've seen how we use the online front end to create a demo or prototype, and not just prototype, but also learn how the framework works. So that's the second step, defining these blueprints of what the user wants to do. Once this blueprint is created, sourceCREATOR has a compiler. In this case, we were running the compiler or the code generator on the cloud server. It turns the blueprint using the definition of the smart templates that came from, say, hardware in this case. The code generator turns the blueprint into a final source code. So in our demo, the final source code that we generated was this code on the right side. Then what happens is that this code that comes out of the compiler is basically completely independent of sourceCREATOR. You can take this code and do whatever you want with it. as you were supposed to without the source creator. So this helps you run the code on any platform, build it for any target, and continue your workflow without source creator blocking you in any way. So that's it, how it works. Where are we today? Let's just give you a bit of an overview about where we are today. If I open these slides, you can see that we started a few years ago by developing the concept. Then we created an application that was just a very, very simple proof of concept to see how this feels in practice. We created a desktop version, and later on, speaking to people like Hardware.io, they expressed an interest in online versions of our compiler. So we developed a simple online demo essentially, and now we are working on how a real complete minimal viable product should look like, and we are starting to look at technologies like Visual Studio Code and web-based technologies to make sure that a real proper functional version of the application works across different platforms as well as the web. Thank you very much.